the next thing I want to do is let's bring over the particles. So I'm going to just stop this and hop back over to Houdini. And that's the wrong file. Let's go over here. Cool. So I'll just get out of here and let's go into our pop network. So if I get really close here, you can see that we've got our particle simulation. It's playing along. It's got quite a few particles. Let's just see how many we've got. Under our pop cache here, I've got 1.3 million particles. Now, you can bring particles over using Alembic. I find that it's just not as flexible for me. So if there is a proxy exporter in your renderer of choice, I would recommend doing it that way. And I'm going to show you how to do it using Redshift right now. So we've got our particles here. We've cached them out. One thing I want to do is I wanted to randomize this P scale so that I can get an actual sense of just the varying sizes of dust particles, basically. So what I did was I threw down a randomized P scale. I set it to randomize my scale, and I just set it to randomize between a value of 0.0001 and 0.001. And then you can just notch this ramp over so that there's very few large particles and most of them are much smaller. That's all this node is doing. And then I just threw down a sprite. The sprite just helps me visualize those sizes. Again, so like if I zoom in, you can kind of see that it's put these little spheres here for me. So I can kind of visualize the size of my dust. It slows things down quite a bit just because they are little sprites that are being drawn a million or so times. So, but from here I could actually determine, like, do I want my value to be 0.01 or 0.05? And then you can kind of see how that is changing things. And then when I dial this this ramp in, and maybe if I were to bring this this notch of the ramp like way down in value, you can see that I get just a couple, just a few really large points, and then many almost microscopic points, like so. So that's kind of what this ramp helps you do. I'm just going to undo that, get back to sort of where I was. Wait for this value. Yeah, so this is sort of where I was in the first place. Now, exporting with the sprite turned on does not work, so I'm just going to mute that. The other thing I want to do at this point is when I hop over to when I throw down my Redshift proxy export, it's not going to necessarily work right off the bat. It doesn't. It needs. There are certain things that you have to set on your nodes to get Redshift proxy to behave appropriately. So typically what I do at this point is I'll actually maybe just do a really super rough render in Houdini using Redshift just to make sure that I'm sort of getting something that I like, because then I know that when I export my proxy, it's going to all translate over. So let's just add a Redshift render view over here. So I'm going to do split pane top bottom again. I'm going to add I'm going to right click on my scene view and select Redshift render view. So now I've got a render view over here. Definitely make sure that you don't still have your IPR going over in Cinema. If you're doing any rendering in both apps at the same time, that's trouble for sure. But yeah, when we're over here, I'm going to just click the play button just to see what we end up getting. And I'm going to select my camera shape here, and nothing happens. So I'm going to just unclick that and click it again. So now our camera's in position and we can see no particles. So what I'll do is I will actually add up here on this geometry where we're saying import pops. I'm going to go up to my object tab right here. I'm going to turn this on first off. Still nothing appears here. Turn this off and back on, nothing appears. Now on the Redshift object tag, you have to explicitly tell it on the particles tab down below that you want to render the object as particles. And then if I hit the turn this play button on and off, particles start to show up. You can see them in there. Important note about why I ended up setting this P scale over here. If you don't have your P scale set before you start using something like the sprite node, your P scale by default is going to be 1. And when it's a value of 1, basically all of these particles are going to be overlapping one another. And it just, for whatever reason, the computer does not like that. I think it's just a lot of overlapping writes to the graphics card or something like that. So I generally tend to scale my particles way, way down before using the sprite node. And same situation applies down here. If you haven't scaled or added a p-scale attribute to your particles before you get into this, before you get into any IPR testing, it can make Redshift totally crash as it's trying to like instance little spheres onto all those particles. So just something to be aware of. At any rate, now that we have enabled our particles on the Redshift object tab up here, we can do some other stuff. So when I ended up creating my debris source way back here, this debris source is also contributing to creating our particle network. And I also added some attribute noise here, and I added some noise, some color noise to these particle emissions. So I find that like one thing that is super handy for me is if I've got a bunch of particles and I want to have some noise or color noise in them, what I will often do is I'll create that as a color attribute, and I can actually store that on my particle geo when I bring it over. And if I bring over a grayscale ramp of, you know, some range of noise that I want to just add a little bit of variation to my particles, I can actually drive that in the Redshift render on the cinema side. So let me just show you what I'm talking about here. If I'm in my pop net right here, these all actually have color on them. I'm just going to add my geometry spreadsheet here. See, these all have color attributes. They also have a bunch of other attributes like age, death, if they're dead or not. If I middle mouse click here, you can see there's just a whole bunch of little attributes. It's really hard to see grayscale right now, so I'm just going to throw down a color node. And what I can do from this color node is I can actually create a ramp from attribute. And I'm actually going to create a ramp based off of the color. So color coming in, and then I'm making a ramp. So I'm just going to adjust this to 2 different colors to make things more obvious. You can see that there is a little noise pattern that I added in here. We'll learn how to do all this stuff later, but really the point of this part of the lesson is to illustrate is that we can, you know, carry color attribute through and bring it into our Redshift object as a proxy, and then have it be translated and able to be manipulated on the cinema side. So I've got this color here. Cool. I've demonstrated that there are color attributes we can use to, you know, readjust the color in post, if you will. So I'm going to delete that. But so the color information is there. Important to know. But in order for the color information to actually be used on the cinema side, we need to actually assign a shader to this. So similar to how we were up here and we had to assign, you know, we had to explicitly tell this to render as particles. We also have to assign a material. So here you can see I've actually already done that. I'm going to delete that out, and I'm just going to go back to, you can see I don't actually have a mat net in here because I was planning on just redoing that for this lesson. So if I go back over here, we have no material assigned on our particle object. So I'll go and create one. So let's go over to the mat context here, and I'm just going to throw down a RS material builder. Like so. Gives us a Redshift opnet. I'll just call this particles. And I'm just going to dive inside. I'm going to create a Redshift material. I'll just wire this into the surface, and then I will create a Redshift point attribute. So RS point. RS point attribute will allow me to take any of these attributes and ramp them, map them, whatever. I could say I want the emission amount, the emission value of these particles to change as they get older. I could use the age attribute, anything I wanted. But in our case, we just want color. By default, it's grabbing UV tangents. I'm just going to change this to our color attribute, which is CD, which we've been using for everything. And I'll just wire that into, let's say the, just to make things easier to see, I'll wire that into the overall emission color. So it's wired into our emission color. I'll go back to this material, and under overall, I'll set the emission weight to be something like 2, just to make this more obvious. I'll also put down a ramp on this side to make it so that I can actually more visibly see. I find black and white to be kind of hard to see sometimes. So I'm just going to select 2 wildly different colors to make some contrast and just pinch those in. So it's very contrasty. And now if I go back out to my object level, grab my import pops node, select from this pick list my matte particles material, hit accept. Then I go back over to my Redshift render view and hit render. Hopefully I get some emission on my particles. You can see that red and blue emission that I created is actually showing up, which is great. But when I export it, I don't want to export it with this drastic of a ramp on it. I actually want to keep it grayscale so that I can add my ramp in Cinema and have that work out. So I'm just going to actually I'm going to actually wire this into the diffuse color. I'm going to delete this ramp. In fact, I'll just hold Y key down and just disconnect that in general. So now all we're doing is we're basically creating a material with this particle lookup going in. Now, I don't know why that this is 100% necessary to do for when you're exporting a Redshift proxy. It doesn't seem to want to take the color attribute with it unless you hook it up this way, unless there's some other way. I have not found that yet. So just a weird one of those quirks that you got to kind of work around. But now if we go back out to our object level and into here, this is pretty much ready to export in terms of its material setup and everything. We've got our scales and our materials ready to go. The last thing to do is just to clean it up a little bit. So I have all of these attributes that I really don't need, a lot like how we deleted them out of our Alembic section when we were exporting our rigids. I'm going to want to get rid of these. So let's throw down a attribute delete. And let's see here. Middle mouse clicking, I got all of these things. Really all I want is p-scale and color to be left over, so I can do one of these guys. I'm just gonna throw down an asterisk and that'll delete everything except, and then I use this caret key, except p-scale and except colors, or CD. So that's gonna keep my color attributes on there, but it's gonna get rid of all those other attributes. That's cool. Then I don't need any of these other attributes, and I don't need this group either. So I'm going to just put in stars for the rest of these fields. So star and star. And then I'll throw down a group delete like so. And I will just delete this. I'll delete any groups that are appearing here. So now when I middle mouse click, everything is all cleaned up. So here's where another subtle scaling issue between Houdini and Cinema 4D shows up is a lot of times, just like similar to how we scaled up our VDB and our density changed. Likewise, our p-scale attribute, if we were to scale this up by 10, our p-scale attribute would remain exactly the same. So what would happen is I would actually increase the size of this whole simulation, but our particles would still remain to have the same p-scale. Therefore, they would appear to have shrunk. So to illustrate this, I'll just use this sprite again. Basically, if I go here and throw down a transform, and I just wire this in here, and I scale this up by 10, you can see that it has made our sim much bigger. But because all I'm doing is viewing particles over here, you can't really see. So let me just throw down my sprites again. So back here, before we scaled it up, these are our sprite sizes. So I'm just going to back out. You can see this is how big this is how big our sprites are. If I go into our geometry spreadsheet, you can see our p-scale is on the order of in the 0.004 range, between 0.001 and 0.0001. So now if I scale this up and wire this sprite in after the scaling, you can see those p-scale values, they have not scaled up along with it. So when I zoom out, you get a much almost less dense appearance of all these particles. It almost looks like nothing's there anymore. So to compensate for this, you would have to do something similar. So you could throw down a point pop. like so. Wire this in, dive inside, hit your bind import your p-scale attribute since it's not part of our globals. So bind. I'm going to bind in p-scale, and I'm simply just going to export p-scale by doing a bind export. Throw that in there. Don't even need these two nodes. Not even relevant in this situation. Just delete them. So we've got our p-scale coming in and our p-scale going out. So bind export set to p-scale, bind import set to p-scale, and here I'll just do a multiply constant. And I'll just throw this one in here and this one in here. And we'll set the multiplier to 10 since that's what our universal scale is that we had set. So now if I were to go and wire this in, our sprites, now that we're 10 times the size, look the way they did when they were wired in down here. Oops, sorry, back here. So if I zoom into this, particle size looks right. So I scale up the actual physical positions of the particles and then explicitly tell the actual particle scales to scale up as well. Wired in down here. And it looks like if I back out, everything is scaling appropriately. So from here, I could do my Redshift proxy export. So Redshift proxy stop. Oops, sorry, not that one. I want the ROP proxy. Or no, it's sorry, Redshift. See, I got it. Proxy. Yeah, okay, Redshift proxy output. That's what we're looking for. So now I've got my output node. This is similar to like the other nodes, like a file cache or an Alembic output. I just wire this in here. I render my frame range, and over here on the archive tab, I can just choose a little place for this to go. So I want to put this into its own folder. So I'll put this in hip/rs proxy export, and then we'll just name it something like $OS. For this Redshift proxy out, I'll call this dust. And it will export this and into this directory with the name dust and then whatever the frame is as well. So that's how you can do that. Now, one thing that I find like works really well is instead of doing this scaling over here in the on the Houdini side, you can also do the scaling in Cinema the way you would actually expect. So if I had skipped these two steps and exported this just at whatever size we had done the sim in at 1/10 the scale, and you were to scale it up manually in Cinema, scaling on that side, scaling of the Redshift proxy archive will yield a true scale the way that you would expect it to. So I'm just going to I'm going to just export this into the directory, and we'll take a look at what we get on the other side. So I'm just going to hit render to disk. And you can see it starting to do its thing there, and I'll catch you when this is done exporting. So, all right, so that is finished exporting the dust particles. You can see here in my directory that it has created this, the RS proxy export folder, and we've got all of our dust is individual RS proxies. This is very similar to how the VDBs work out, where it writes an individual file for each frame of your animation, and you can see that they're, I don't know, relatively small, which is cool. These can get insane if you've got a very large number of particles, but essentially Redshift has done a lot of the legwork in terms of rendering this, so it's actually very efficiently extracted on the other side. So let's bring this into Cinema. We're going to hop back over to our Cinema project here, and just going to minimize this and close this. So here, what we want to do is we want to import a Redshift object, and we're going to choose Redshift proxy. Similar to like how the volumes were. I mean, the interface is almost exactly the same. Here we want to choose our proxy file. So we select, go navigate to our proxy export folder and select dust 000 and say open. It asks to copy it. We say no, leave it where it was. And then we'll go into our animation section. And I'm going to choose simple mode again. Whoops, simple mode. Timing frame, that's good. I'm going to change the frame rate again to 24 and then choose detect frames. And here, now we should have a proxy file in our scene. Let me see if I actually uncheck the volume. So I've disabled my volume. You can see that the bounding box for the Redshift proxy is in our scene as well. And it's taking up pretty much the same area as our volume is. So, and you can see that it is animating in size as we scrub our timeline. So that's all good. So let's just, I'm just going to turn off our RBDs as well right now and fire off a render just so I can see if the particles are showing up. So I'm going to open up my Redshift render view, which I think it's actually minimized. So I'm just going to bring it up here and I'll just hit the render button. So we've got our particles here, and let's now try and let's just do some custom shading on the cinema side. So we've created that black and white attribute. We've created a P-scale attribute. So we've got our scales accordingly. Everything's scaled and lined up with this current scene. We just need to access that color attribute so that we can start dialing in our own shader on the cinema side. So I'm going to create a new Redshift material in order to do that. So we've got our new Redshift material. I'm going to call this particles. And I'm going to assign it to our Redshift proxy. And by default, nothing happens. That's because the Redshift proxy is set to take materials from its proxy file. I'm just going to select take materials from object instead. And now they change like a darker gray. That's just because it's taking sort of a basic material out of our scene. So it is now reading off of this Redshift shader. We just need to do a couple little things in the Redshift shader graph similar to how we did in the shader graph in Houdini. So I'm going to hit edit shader graph. It's going to pull this guy up. And I'm just going to stop the render for right now. So with this shader graph up, I'm going to it gives us our material. That's good. I'm going to just bring in our point attribute. So I'm going to do rs point. Oops, I'm just going to say point. Yeah, so we get this point attribute here. I'm just going to drag that in. And the color coming from the point attribute, I want to just wire that into, let's just do emission for right now. Overall emission color. And to make it drastic and obvious, I'm going to go into overall, set the emission weight to be something super high like 2. And then on the Redshift point attribute here, the attribute name, and we got to know this because we assigned this attribute name in Houdini. So we just got to write down CD, just like we did on the Houdini side. And again, because I find black and white to be kind of hard to see, I'm just going to pipe this black and white value through a ramp so that I can make it more obvious. So let's throw down a ramp. Just going to wire this over here. Like so. Oops. Bring that in here. Oops. All right, and then this guy in there, like that. Awesome. And I'll just set these colors to be some really crazy, like hot purple and lime green, like so. Oops, give me lime green. Yeah, just got to saturate it. That's good. All right, let's bring these guys really tight together in the beginning, or in the middle, rather. You can see we've got some purples and some greens, which is great. So that means that it's taking our color information and bringing it into our scene. So if I go to this ramp, I could, definitely do whatever I want now to kind of make this a little bit more, pleasing. Obviously, probably wouldn't be doing anything with emission in this scene. I'd want to kind of get a nice dust look and dial all these shaders together. So I might do that by going into something like, let's see. I would maybe wire this. Oops, let's just double click that. I'd maybe wire this output color into the diffuse channel instead. Remove diffuse color. Make this ramp maybe something like, maybe just not fully white on one end, but maybe like a gray. And then over here I might do some more of a tan color, so we get kind of these two different colors. I really don't want this going into emission color anymore. I want it to be going into the diffuse color, so I'm going to do that. I'm going to unwire the emission color. So there, then on our Redshift material, I'm just going to turn the emission weight down, and then from here you're just kind of doing the normal art directing thing. I'll maybe bring the reflection weight way down and bring the diffuse weight down. You know, from here it's totally subjective, but we got all these particles. They're rendering. It's looking great. They're starting to look great, rather. I feel like that's a little bit too saturated. I could dial it back some, maybe bring it down in terms of its gray level, maybe bring its value down a little bit, something like that. Looks like dust. Looks pretty dusty to me. Like kind of like how it's mixing with these shadows here. And let's just reintroduce the volume. On our volume, we could, you know, mess around with some values in terms of how it's scattering, but I kind of like the way that this volume accompanies these particles, because it makes it appear as if the dust is ranging from the very large particles of dust to the almost microscopic wispy particles of dust. Just get into the redshift volume here and go to the scattering coefficient, maybe dial that down just a little bit. I'm going to switch back to IPR mode. Maybe I'll just shift select a little region so that I can look at this. Maybe scattering a little bit less, making this top color a little bit darker, maybe adding a little bit less absorption. See how that looks over here. I've just made it go away. I'll just bring that scattering coefficient back up until I see sort of a combination that I'm after. Maybe switch back to bucket mode. You really kind of get that dirty, dusty look going on with this shot. Again, I'll just turn on the RBD, just to add it back into the mix. And maybe at this point, I'll also turn back on motion blur. And I'll just turn off the crop region and turn off the actual IPR and kick off an actual and see how kind of all these elements are looking like together. Obviously, there's a whole bunch of shading that needs to be done in this scene as well to get it to look right. The lighting isn't that great, honestly, but you know, it was just something quick and dirty to kind of get you guys familiar with the workflow. So hopefully this was helpful to understand how to get objects out of Houdini and into Cinema 4D in a workable, renderable state. I think it's pretty important to know, especially if, you know, Houdini isn't your number one tool. You're going to be working with other applications. It's important to bring all these things together. So yeah, you can see that we've brought all of our elements together. That's great. I'm just going to stop this because this render is not particularly pleasing to the eye to begin with. Honestly, it's kind of a garbage ad campaign to begin with. I don't know who would want to be buying a golf club. If we're selling the golf club, I don't know who would want to buy a golf club that destroys golf balls. And if we're selling a golf ball, I don't know who'd want to buy golf balls that would be shattered like this. So really, I don't know. It was the first thing I could think of, but it was able to allow us to bring in all the separate elements and show how you can get those objects in and out of Cinema 4D. So that's it for the part one. This is really, you've learned everything that you need to know to get on to doing the simulation stuff. So now we can start doing simulations, we can start doing more interesting things, but really I feel that at this point you should feel relatively solidly onboarded with all the ins and outs and not knowing what you don't know type things that come along with learning a new piece of software. So I will catch you in part two, where we will start to actually do some particle simulations, some fluid simulations, just all the simulations. And it's going to be a lot of fun, and congratulations for making it this far. And I'll see you in the next part.